What we're looking at here are the solutions to the problems on page 130 to 132, 1 through 6, and we have a number 9 and 10 also. So the first one here, we're doing a proof, and the given was that angle P was congruent to angle S. So our first reason here obviously is given. And we were also given that O is the midpoint of PS, so number 2 is also given. Those should be the easy ones. Now the next thing we have here, my recommendation is when you're doing these, to mark what is given congruent. So we're going to mark angle P and angle S congruent. And then we say PO is equal to SO. Well, how do we know PO is congruent to SO? Well, the reason is we were just told that O is the midpoint of PS. So the reason we know those are congruent is by definition of a midpoint. After that, we have angle POQ is congruent to SOR. Why is this angle known to be congruent to this angle? Well, the reason we know that is because vertical angles are congruent. So vertical angles are congruent. Now, if we look here, we have two congruent triangles now. I didn't have the symbol here available in Smart Notebook, but triangle PQR is congruent to triangle SOR is the next statement they give you. Why are these two triangles congruent? Well, if you look here, we have a set of angles, then a set of sides, then a set of angles. And those sides are between the two angles. So this is angle, side, angle postulate. Angle, side, angle. And after that, we say, well, then QO must be congruent to RO. QO must be congruent to RO because they're corresponding parts of congruent triangles, which are congruent. And that's my CPCTC. And once I know that those two are congruent, I know O is the midpoint of segment RQ because the definition of midpoint, if I have two equal parts, then it must be a midpoint. And that's how you do number 1. The next problem just asks you to put them in order. Answers could vary. They have A, E, C, F, B, D. I say also that A, E, F, C, B, D can be done. Really, the important thing is B should be second to last and D should be last because that's what we're trying to prove. A and E are given, so I would put those there. C and F are actually interchangeable because they're not dependent upon one another. The next one is proof. We're trying to prove that angle W is congruent to angle Z. If you look here, we say, well, if we could prove these two triangles congruent, we would know that those were congruent by CPCTC. So, making your proof, I would say step 1, put the given. Now they have congruent here, I just put equal because I didn't have a congruent symbol available. So they have segment WO is congruent to segment ZO, and segment XO is congruent to segment YO. And like I said before, it's a good idea to mark what they give you congruent. This is congruent to this, and this piece is congruent to this piece. So now if you look here, you might say, oh, wait a minute. It looks like I have side angle side. If only I knew that these two were equal. And we know that those two are equal because these are vertical angles. So for step 2, we say angle WOX is congruent to angle ZOY. And the reason is vertical angles are congruent. That's vertical angles. Number 3, step 3, say, oh, well then we have two congruent triangles, and we say triangle WOX is congruent to triangle ZOY, making sure that we put them in the right order when we name our congruents. And the reason here, side, angle, side, postulate. And our last statement then, remember we're trying to prove W and Z were congruent, so we say, oh, angle W is congruent to angle Z because they're corresponding parts of congruent triangles, so they're congruent, CPCTC. Number 4, we're given that M is the midpoint of AB. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So we're going to put all that down in our given. M is a midpoint of segment AB. And we have angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. We're trying to prove that AC and BD are equal, this and this. Now do you see if we had two congruent triangles, those would be congruent by CP/CTC. So I'm going to try and get two congruent triangles. We'll have a set of angles and another set of angles already marked congruent from this. There's a set of angles, set of angles. Well, we know that we need another side in between, because angle side angle is the one that uses two angles right now. So we need this congruent to this, AM congruent to MB. All right, so those two segments are congruent. The reason we know they're congruent is because we're told that M is the midpoint. So definition of midpoint will tell us that that's true. Step 3, state that we have two congruent triangles. Triangle CAM is congruent to triangle DBM. And the reason, that's angle, side, angle. And our last step would be to say that AC is congruent to BD. Reason, CP/CTC. Number 5, right here we have SK is parallel to NR. So we have parallel lines here. And SN is parallel to KR. This side is parallel to this side. And what we wanted to prove was that if we have a quadrilateral with opposite sides parallel, that the opposite sides are congruent. So we're going to prove that these two are congruent and these two are congruent. Now this may have two things we're trying to prove, but they're both going to be done using CP/CTC once we have two congruent triangles here. So let me move that a little closer. So I'm going to draw my T-chart here. And step 1, I'm going to say my given, SK parallel to NR, and SN parallel to KR. And that's given. Now if we look here, we want to prove these two triangles congruent. Well, if we have parallel lines, we know that alternate interior angles are congruent. So I'm going to go ahead and say angle 1 is congruent to angle 3. And I also know that since these lines are parallel, that angle 2 and angle 4 are also alternate interior angles. So that's step 2. And the reason alternate interior angles are congruent when we have parallel lines. Step 3. Now if you look here, we have an angle and another set of angles. We need a set of sides in between for angle, side, angle. That's the only one that uses two angles right now. And that's going to be SR, which they share. So we'll say SR is congruent to itself. And the reason for that, the reason we're allowed to say that in geometry, is the reflexive property. That's the reflexive property of congruence. Now we have two congruent triangles, so we say triangle SNR is congruent to, now we got to be careful when naming this one, SNR. Well, angle S on this bottom triangle goes with angle R in this top triangle, right? So it's R, and then angle N goes with angle K, K, S. Don't assume that the S's have to line up, because this triangle up top has a different angle at S than the bottom triangle does. Okay, and the reason here, angle, side, angle. So we have an angle, side, and an angle, with the side in between the two angles. And then step 5, once we have two congruent triangles, we say OK, SK is equal to NR, and SN is also equal to KR, both for the same reason, which is CP/CTC. Number 6, we have the converse of that, saying that if Sn equals Nr, oh, that's not right, hold on. Right, sorry about that, there was a little typo there. It says Sk is equal to Nr, or Kr, and Sn is, hold on a second. Okay, sorry, Sk is congruent to Nr is here, and then Sn is congruent to Kr is there. So when we do our proof, it's going to look a lot like the last proof. So step 1, we have Sk equal to Nr and Sn equal to Kr given. Now in the two triangles, that's a set of sides and a set of sides. When we have two sides, we could do side angle side if we had an angles congruent, but we don't just yet. But we also know that they share SR. So for step 2, I would say SR is congruent to SR. Remember, these were congruent. And remember, that was reflexive property of congruence. And now we have two congruent triangles by side, side, side. So there's another set of sides, side, side, side. So we say triangle SNR is congruent to triangle RKS, and the reason, side, side, side postulate. Once we have those congruent, we say, all right, well, if those are congruent, then angle 1 corresponds to angle 3, so angle 1 and 3 are congruent. And also that angle 2 and 4 are congruent. And the reason that those are congruent, CP, CTC. And now those angles being congruent give us parallel lines. So SK is parallel to NR, and SN is parallel to KR. And the reason is alternate interior is congruent. That's it. Number 9, it says, what information do you not need here? There's actually more than one way to do this one. What I'm going to do is, I'm just going to say, one of these pieces of information was not needed. They gave you PQ is congruent to PS, and QR is congruent to SR, and angle 1 is congruent to angle 2. What do you see with this picture? We actually have PR is congruent to itself. So we have two congruent triangles by side, side, side. Now if you ignored one of the other pieces and used the angles, then you could prove the two triangles congruent by side, angle, side. I'm going to prove them congruent by side, 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 and get rid of angle 1's congruent to angle 2. So I'm just going to put some of the key steps here. You probably know to put the given and everything like that. So down in step 2, you would probably say PR is congruent to itself. Oops. Mistake there. Step 2, PR is congruent to itself. That's reflexive. And then you would say the two triangles are congruent. Triangle PQR is congruent to triangle PSR. PSR. Sorry, it's a little sloppy there. I'm running low on time here. The reason, side, side, side. And then you'd have 3 and 4 congruent by CPCTC. Okay. And number 10. Number 10, we have LM equals LN, KM equals KN, and KO bisects MKN. I'm going to get rid of this one here because that's the easiest way to do this proof, because then you're given this is congruent to this, and KM is congruent to KN, and then if you look, they both have LK. So then I know that LO will bisect this angle because I can show that these two angles, angle 1 and 2, are congruent. So first I prove the two triangles congruent by side, side, side. And then I'll say angle 1's congruent to angle 2, and that'll be CPCTC, and then I'll have a bisector by definition of bisector. And that's it.